Hello everybody, I'm Dr. Satoru Sumitsuji from Osaka, Japan. I'm very happy to have the chance to join my presentation in the European Bifurcation Club meeting. My presentation title is Clinical Potential of Myocardial Mass at Risk Calculated by a novel software utilizing the cardiac CT. This is my COA disclosure. First, what is a MMAR? MMAR is a myocardial mass at risk. That is just a territory. The territory on any point on the coronary artery tree. You know the territory size is very important, like the ischemia. This is the data from the college trial. As you know, bigger size of the ischemia closely related to the death or myocardial infarction. Like that. Before the nuclear era, there is an angiographic jeopardy score. That is risk assessment from the with using the angiographic data, angiogram. This is a body jeopardy index. Duke approach, there's some the method, and all of the angiographic jeopardy score have the predictor, can be the predictor because higher angiographic jeopardy score clearly related to the 1-year mortality. Territory size is important predictor of mortality. So how to get the territory size? Nowadays, we have several of the imaging modalities: CT, MRI, echo, angiogram, SPECT PET. In them, just only the CT have both of the information, the high-level information of the coronary artery and the myocardium. So, using the information of the coronary artery and the myocardium, from the coronary artery, making the 3D tree, and then combine them. Also using the Voronoi method. Voronoi method is segmentation algorithm. Originally, this is a two-dimensional algorithm, but we modified and then using in the three-dimensional space. One myocardial boxer expanding like the balloon, and then touch to the coronary artery boxer. This is the nearest coronary artery boxer to this myocardial boxer. And this myocardial boxer is territory of this coronary artery boxer. This is the algorithm, hypothesis and algorithm. And we do all of the myocardial boxer using the same algorithm. Then each boxer of the myocardium could be defined their corresponding the boxer in the coronary artery. After that, we put the one index point on the coronary artery. And then making the summation of all the related myocardial boxer to this coronary artery boxer. This is to the index point. This summation is territory. This method is not only for the heart, actually already used for the liver and the lung. Surgeons use before the surgery making the segmentation within the CT information, and then they do the lobectomy or some kind of the operation. In heart, how can we use it? This is one case, the diagonal total occlusion. This tool is not so very big. Is this a very big theater of the diagonal or smaller diagonal? That's very important to make the decision. But there's no definite answer from the angiogram. CT can tell us, okay, this diagonal have the 20.7% of the whole left ventricular myocardial mass. That is huge. Look, the LAD without this diagonal is 22.6%. This big diagonal can be the target of the revascularization. Another interesting case, Like coronary total occlusion after the myocardial infarction of the RCA, and then like coronary total occluded, but almost no collateral flow. You can see just only the septal here. Why? Answer is here. CT shows myocardial damage is quite severe in the inferior wall. Look here. Which coronary territories? Of course, like coronary, but we can make more sure with the MMAR assessment. This is a like coronary segment. This is circumflex segment. And then the later coming, this green is LAD segment. Only the like coronary segment have control damage and thinning. So we have the strong how to say belief about the accuracy of the software and the algorithm, but we did a validation study. First one is a validation with a cadaver heart. Cadaver heart, how much the myocardium, the three major coronary arteries has for whole heart, not the left ventricle. LAD 41.7 with the cadaver heart data and the 40.8 with the MMR data. Like this, circumflex, RCA, very similar data. And we did the intra and the inter-observer the analysis that shows this is a very nice how to say reliable. So anybody can do it for this analysis. And another validation study is animal heart. This study was done by my colleague Dr. Ide using the ink and the CT. The relationship is very nice. R square is 0.74. So now we can use this algorithm for the clinical data, clinical case. One case is LAD CTO with a bifurcation. Here, this is septal. This is LAD and this is diagonal. LAD total occlusion, but in the distal territory, diagonal looks very big. How big it is? We never know with the angiogram because this is a total occluded segment, but CT can tell us very clearly. This is the MMR result with the segmentation for each branch. Then LAD CTO segment have almost 1/3 of the whole left ventricular myocardium. And another important point is the diagonal. Diagonal has almost 40% of the total occlusion myocardium. It means just only the revascularization for the LAD is 60% success. So we should keep the both, we should do the revascularization both LAD and the diagonal. Actually, untagged wire nicely packed into the distal lumen like this. But after the pre-dilatation, we lost the diagonal. So in this situation, just put the stent is 60% success in terms of the myocardial saving. Like this, 40% is a diagonal. So we did the reverse wire technique to save this diagonal. Very nicely done, the reverse wire technique. Then put the stent to the diagonal, put the stent to the LAD and KVT, and the final result is this. This is complete success. Reverse coda both LAD and diagonal. This is my summary. It is completely agreed that territory size of the target lesion is important for indication of the PCI treatment. Current most reliable assessment of territory size of target lesion is CT because only CT has high-level information of both coronary artery and myocardium. Assessment of the CT-based MMR is available at each point on the coronary artery tree, including branch ostium. With using the MMR information, we can optimize bifurcation PCI with the best strategy for branches. Thank you for your attention.